Every single app on your phone, every program on your computer has hidden flaws. They're like tiny cracks in the code that can lead to crashes or, even worse, major security breaches. But what if I told you the secret to finding these bugs more efficiently comes from a swarm of bees? Yep. Today, we're diving into a fascinating new method that takes its cues directly from nature to help make our digital world a whole lot safer.
All right, so here's our game plan. First, we'll get into how we automatically hunt for bugs, and you'll see why the way we've been doing it is, well, kind of wasteful. Then, we'll meet the hero of our story, a smarter system called MOpt. We'll see how it literally learns from nature, and then, my favorite part, we'll look at its absolutely stunning results. And finally, we'll wrap up by talking about what this all means for the future of software. So, how do we find these hidden flaws in the first place? Well, cybersecurity experts use automated tools, and one of the most powerful techniques out there is something called fuzzing. Okay, I want you to imagine a security guard trying to find a faulty lock in a giant skyscraper. But instead of a key, they just randomly jiggle every handle, push doors, and pull in slightly different weights, over and over. That, in a nutshell, is mutation-based fuzzing. It takes a totally normal file, like a photo, and just starts messing with it, flipping little bits of data here and there, adding random junk, and then it throws millions of these mutated versions at a program, just waiting for one of them to make it crash. That crash, that's like finding the unlocked door. It means you've just found a hidden bug.
Now, this is a really powerful technique, for sure, but it has one major flaw. It wastes a colossal amount of time and energy. Let's dig into why. So the most popular fuzzers, like one called AFL, have a whole set of tools for changing the data. You can think of these as mutation operators. But the problem is, their strategy is super simple. They just pick a tool from the toolbox at random, giving each one an equal shot. But think about it. Is trying to test a lock with a feather just as effective as using a hammer? No way. And here's the proof right here. When researchers actually watched one of these fuzzers in action, they found something incredible. Just 3 specific mutation methods were responsible for finding almost 70% of all the interesting results. And the other 9 methods combined, they only found the remaining 30%. This means the fuzzer was spending a huge chunk of its time on strategies that almost never work.
So the crucial point, the big takeaway is this. Traditional fuzzers are brute force workers. They're incredibly persistent, I'll give them that, but they aren't intelligent at all. A massive amount of computing power is just being wasted on strategies that almost never find bugs.
So, how do you fix a problem like that? Well, this is where our story gets really interesting. Researchers came up with a new approach called MOpt, and it brings some much-needed intelligence into the brute force world of fuzzing.
This really lays out the difference perfectly. The old way is totally blind. It treats every tool in the toolbox the same. MOpt, on the other hand, is a learning system. It actually pays attention to which methods are finding bugs and then focuses its energy on those winning strategies. It is the classic, beautiful shift from just working hard to working smart. Okay, so how in the world does MOpt get so smart? This is the coolest part. It takes its inspiration from one of the most efficient problem solvers on the entire planet, the swarm. MOpt uses a concept called particle swarm optimization, or PSO. Now, don't worry about the fancy name. The idea is actually super intuitive because it's inspired by how birds flock or fish school. Imagine a group of these particles searching for the best solution to a problem. Each particle remembers its own personal best find, but it also knows about the single best discovery made by the entire group. And that social feedback helps the whole swarm quickly zero in on the best answer. The best way to think about it is with a swarm of bees hunting for nectar. Each mutation method is a bee, and the nectar, that represents the software bugs. Now, each bee remembers the best patch of flowers that it has found personally. But, and this is the crucial part, every bee in the swarm also knows where the single best patch found by any bee is located. This collective knowledge pulls all the other bees toward the most promising areas. Over time, the entire swarm starts to focus its energy on the richest source of nectar. That is exactly how MO optimizes its hunt for bugs.
So, does this whole bee-inspired approach to finding software bugs actually work? Well, let me tell you, the results aren't just good, they are absolutely jaw-droppingly stunning. So get this, when the researchers put MOpt into the standard AFL fuzzer, it found 350% more unique crashes. I mean, let that sink in. That's 3.5 times more potential bugs, just by being smarter about how it searched. That's not a small improvement, that's a whole different league.
But hey, finding crashes is one thing. Finding actual security flaws, the really dangerous stuff, is the real prize. And here, MOpt AFL found 170% more verifiable security vulnerabilities. This wasn't just finding more noise, it was finding the bugs that truly matter.
And if you need the ultimate proof, here it is. In tests on 13 real-world programs, software people use every day, MOpt found 97 previously unknown zero-day vulnerabilities. These are the most dangerous kinds of flaws, because the developers don't even know they exist yet. Real bugs discovered because a swarm of virtual bees got a little smarter. Incredible. And as if all that wasn't enough, MOpt has another trick up its sleeve. You see, the original Fuzzer had this really slow, methodical stage where it wasted over 70% of its time. MOpt's pacemaker mode intelligently skips this unproductive phase when it's not working, which accelerates the learning process even more and lets the swarm get back to its efficient bug hunt. Okay, let's just step back for a moment and look at the big picture. Because this isn't just some clever academic exercise, this has real-world implications for every single one of us. The takeaway here is really simple. More efficient bug hunting means developers can find and fix flaws way faster, and that leads to more stable, more reliable, and most importantly, much more secure software for everyone. It means a safer digital world built on code that's been more rigorously tested by smarter tools. So we started this journey looking for cracks in our software, and we ended up learning from a swarm of bees. It's just a powerful reminder that some of the most elegant solutions to our most complex digital problems might just be hiding in plain sight in the natural world all around us. It just makes you wonder, right? Where should we look next?